Next one is channelization. So channelization is a multiple access method in which the available bandwidth of the link is shared in time or frequency or through code between different stations. The different station will share the bandwidth of the link either in time, frequency or code. That is channelization. There are three channelization protocols. One is frequency division multiple access, time division multiple access, and last one is a code division multiple access. So first, frequency division multiple access. In frequency division multiple access, the available bandwidth is divided into frequency band. Each station is allocated a band to send its data. Each band is reserved for a specific station and it belongs to the station all the time. The particular station can use the particular band for all the time. Each station also uses a band pass filter to confine the transmitted frequencies. To prevent interferences, the allocated bands are separated by a guard bands. So this is frequency division multiple access. If 4 stations are there, each station is allocated one frequency. So this is the frequency allocated to station 1, and this is a frequency allocated to station 2, and this is a frequency allocated to station 3, and this is a frequency allocated to station 4. That particular frequency can be used by that station for the entire time. So in time division multiple access, the station share the bandwidth of channel in time. So each station is allocated the time slot during which it can send. So each station transmits data in its assigned time slot. So the main problem with the TDMA lies is in synchronization between different stations. So in order to prevent that, each station must need to know the beginning of its slot and the location of its slot. So due to the propagation delay, so it is somewhat difficult. So in order to compensate that, we are using God times. So synchronization is accomplished by some synchronization bits called preambles, which is added to the beginning of each slot. So this is time division multiplexers. This particular time is allocated to the station 1, and this particular time is allocated to station 2, and this particular time is allocated to station 3, and this particular time is allocated to station 4. So it can use that channel at the particular time. Next one is CDMA, code division multiplexing, multiple access. Okay, code division multiple access. So CDMA, one channel carries all transmission time. Here you can simultaneously, the channel will simultaneously carry all the station's information. So this CDMA is based on coding theory. So each station is assigned a code, which is a sequence of numbers called chip. So this code division multiplexers is based on the coding theory, and in the CDMA, each station is provided one code, and it is called chip. So some properties this chip is having: if you multiply each code by another code, you will be getting a 0, and if you multiply 2 code by itself, you will be getting the number of station. So these are called orthogonal sequences. These codes are called orthogonal sequences, and it will have some property. So each sequence is made up of n elements. That is, if you are having n number of stations, then the sequence must have n elements. Then if you multiply a sequence by a number, every element in the sequence is multiplied by that element. This is called the multiplication of a sequence by a scalar. Then if you multiply 2 different sequence element by element and add, and the result is 0. This is called the inner product of two sequence. That is, if you add 2 sequence and if you multiply 2 sequence, and if you add and if you are adding it, you will be getting a 0. And adding 2 sequence means adding the corresponding elements. If you add 2 sequence, you'll be getting another sequence. Data representation. If a station needs to send a 0 bit, it is encoded as -1. If a system or station needs to send 1 bit, it is encoded as +1. If it is idle, then it is interpreted as 0. For 1, it is +1. For 0, it is -1. If it is no signal, then it is 0. So here you are having 4 stations, 1, 2, 3, 4, and 4 stations are having some data D1, D2, D3, and D4. And these 4 stations are having some codes C1, C2, C3, and C4. Okay. Now CDMA receiver. In the CDMA receiver, we will be multiplying first, each data will be multiplied by that particular station with its code. Then all the things are added. And the receiver channel will multiply that with the particular channel. So each in this diagram, you are having 4 stations. So each one is having a code. C1 is having a code of +1, +1, +1, +1, and C2 is having a code of +1, -1, +1, -1. C3 is having a code of +1, +1, -1, -1. C4 +1, -1, -1, +1. Okay. So now station 1 and station 2 are sending 0, and station 3 is silent, and station 4 is sending 1. Okay, so here first what is sending means 0 means a -1. This -1 is multiplied by this code, so we'll be getting -1, -1, -1, -1. Then this -1 is multiplied by this one, so we'll be getting minus into minus plus, so +1 minus into, sorry, this and this and this code, you'll be getting this one, minus into plus minus, again minus into minus plus, minus into plus minus, minus into minus plus. Similarly, each data is multiplied with this particular code and you'll be getting this. After that, you have to add all the first element of the data, -1, -1, -2, -2 +1, -1, -1 plus 0, -1. So we're getting -1 as the first element. Next one, -1 plus 1 cancelled, -1, 0, -1. Third one, -1, -1, -1, -3, 0, -3. Next, -1 plus 1 cancelled, +1, 0, +1. So this is a data what you are getting. So this is signal. So bit 0, it is multiplied by that code, you are getting this one. Similarly, bit 0 multiplied by the code of the channel 2, you are getting this one. The third one is silent, so everything is 0. The bit 1 is multiplied by the code of channel 4, you are getting this one. So it is represented, -1 means below the level, 0, 0, 0. Here -1, +1 means above the line, -1 below the line, +1 above the line. 0 means no signal. So next one, +1 above the line, -1 below the line, again -1 below the line, +1 above the line. Now you are adding all these things. This is minus, minus, -2. -2 plus 1. So you'll be getting -1. So below. Next one, -1 plus 1. If these two gets cancelled, again -1. Here, -1, -1, -1. So -3. Here, this minus and plus get cancelled. You are having +1 here. So this is a data. Okay. So this is the data on the channel. So the second one is going to receive the third station is going to receive the data from station 2. So this is a second station's code. So their inner this is +1, -1, +1, -1. This is a data. This is next you are going for the product, -1 into +1 -1. Again -1 into -1 +1. -3 into +1 -3. Here -1 into +1 -1. So you are getting this data. So next these levels shows the values. Then 0, then it is coming to -1. Again it is 0, then -3, then it is coming to -4. So finally you are getting -4/4. Number of stations, how many stations you are having? We are having 4 stations. So 4/4, that is -1. So -1 means bit 0. The station 2 is sending a 0 bit. So here you have to add this one. Here you have to add this one, that is -1. -1 + 1, -3 -1. These two gets cancelled. Actually how you are getting this value means these two gets -1 and +1. These two gets cancelled. So -3 -1 -4. So totally here you are getting -4 here. So after getting -4, you have to divide it by the number of station. How many station you are having? 4. So it is -1. So getting bit 0. Once again I am telling. So here you are having 4 station. How many station you are having? You are having 4 station, and the station 1 and 2, it is sending the information of 0. So is 0 is sent as -1. So and the system and the station 3 is silent, and the system 4 is sending a 1. 1 means +1. So here what doing is the system 3 is going to check what the system 2 is transferring. So initially what we are doing is, first we are multiplying the each data with its code, and we will be getting one D1 C1, and you will be adding all these D1 C1 plus D2 C2 plus D3 C3 plus D4 C4. So you'll be getting this -1 -1 -3 +1. You will be getting. Now this is multiplied by this C2. Actually, the C3 is going to check what this station 2 is sending. So this data is multiplied by this C2. So you'll be getting minus into plus, minus, minus into minus, plus, again minus into plus, minus, plus into minus, minus. So you'll be getting. So this is a data what you are getting finally. Then this is the inner product what you are getting. Okay, so this is the thing what you are getting by multiplying this data with the code of station 2. Then after getting that result, we have to add this. This is -1 plus 1, 0, -3 -1, -4. So value what you are getting is -4. Now how many stations you are getting? 4 stations. So -4 divided by 4, -4, no, -1. So -1 means bit 0. So that station 2 is transmitting a bit of 0. This is Cdma. So sequence generation. So in the Cdma, you are using one sequence, and that sequence how we are generating using the Walsh table. By using the Walsh table, we are using the sequence. The sequence name is chip. So Walsh table is nothing but a two-dimensional table with equal number of rows and columns. This is an Walsh table. This is W1 and W2N. WN, 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 WN transpose. Okay. So this is W1. W1 is plus 1. W2 means plus 1, plus 1, plus 1, minus 1. W4 means plus 1, plus 1, plus 1, minus 1. Plus 1, plus 1, plus 1, minus 1, plus 1, plus 1, plus 1, minus 1, just inverse. Minus 1, minus 1, minus 1, plus 1. So by this technique, we can generate the chip sequences. Okay. So we have studied the Cdma. Okay.